So we skip all of Chapter 6. There's a few things we may go back and touch on depending on time, since we only have a few weeks left, but there are several important things out of Chapter 7 that we need to look into and cover, so we will be starting 7.1 today, which is solving systems of two equations and thus two unknowns. Okay, so like x and y, we will be solving for those two things here, getting an ordered pair answer. So let's review. We have a couple different ways that we can solve these. So methods include, we can do it by graphing, we can do it by substitution, we can do it by elimination, or you may have learned it as combinations. When I learned it, we called it combinations, but a lot of books call it elimination now, so not sure which one you'd be familiar with, but they're the same thing. And lastly, one that I don't think you've probably seen to this point, but we can just do it algebraically. And you might be thinking, well, don't all of these involve algebra? And yes, you'd be right. But the method in which we do this will look very similar to substitution, but it is a little bit different. So, I can also tell you that by graphing, you can cross that one out. We're not going to use that one. It's just too much up to making sure your graph is drawn perfectly, and quite frankly, I would never use that method by hand. If I did it, it'd be on a calculator. I would use one of these other methods if I had to do it by hand. So, okay. So what we are going to do is we're going to start out just looking at some problems, because like I said, this really should be a review overall other than this one algebraically. So we're going to look at just some examples of each type. Probably not too many, so this lecture really shouldn't take too long, but we're going to start with number 2. So with these ones, it says to determine whether the ordered pair is a solution of the system. Alright, so number 2, we are given y is equal to x squared minus 6x plus 5, and y is equal to 2x minus 7. So the first ordered pair we're going to check is the ordered pair 2, negative 3. So all I'm going to do is I'm going to plug these numbers in each equation, and if it's true in both cases, then we can say yes, and if it's not, then ultimately we will say no. So y is equal to, or I guess I should replace that y with negative 3, is equal to 2 squared minus 6 times 2 plus 5. So I already just have the negative 3 by itself, so it'll just be brought down the whole time. 2 squared is 4. 6 times 2 is 12, so it's negative 12 plus 5. So 4 plus 5 is 9, minus 12 is negative 3. So it works in that one. And you check the other one. So the negative 3 is equal to 2 times negative 2. Oh, sorry, that's positive 2 minus 7. 2 times 2 is 4, minus 7 is equal to negative 3. Negative 3 is equal to negative 3. So that one works, so we can say, yes, that is a solution. Now, just because one of them is does not mean the rest of them are not. Okay, so we do have to go through and check each one of them. So B, try to do this one up here, is 2 and 1. So we're going to do the same thing here. So 1 is equal to 2 squared minus 6 times 2 plus 5. So 2 squared is 4 minus 12 plus 5. This is what we already had, and we knew that was equal to negative 3. And that's not true, so we can go ahead and say no without even having to do the other one. Now, there is a possibility that it may work in one and not the other. So just because you get a yes on the first one doesn't mean there will be a yes on the second one. So just make sure you do check. But lastly, let's do C. It's going to be 6, 5. So let's see. 5 is equal to 6 squared minus 6 times 6 plus 5. That's 36 minus 36, so those are going to go away, leaving you with 5 is equal to 5. So that's good. Let's check the other option. 5 is equal to 2 times 6 minus 7. So that's 12 minus 7, and 5 is equal to 5. So we're good. So we can say, yes, in fact, that is a solution. So you can see there were 2 solutions here. In this case, that worked. So the next set of problems says to solve by substitution. So remember, the goal is in this to first get a variable by itself and plug it into the other equation. So plug it into the other equation. To solve for that variable. And then lastly, plug it back in to solve for the other one. And I think I might have made this comment, but just remember that answers are always written as an ordered pair. Oh, and one other thing that I've also forgot to point out, sorry about that, is that we can have one solution, which would be the ordered pair. We can get no solution, so basically we get a false statement, i.e. 0 is equal to 8. And then the other option is infinitely many. Which means we get something that is like 0 is equal to 0 or 20 is equal to 20. Something like that gives us infinitely many solutions. So rather it being like with these ones, you'd get something like x is equal to some value and you get y is equal to some value. And then you write it as an ordered pair. With these ones, you just get either a false statement or something that's always true, basically. So 0 is equal to 0 is always true, 20 is equal to 20 is always true. And you've probably really only seen this come up with this elimination, but this actually can occur with substitution as well, so just be aware of that. Okay, so now we got through the little logistical things that I had forgotten. Let's take a look at some substitution. And your answers won't always be pretty. Sometimes they're going to be, you know, a fraction or something like that. Now let's go with 8, because this way we get a little bit of everything in here included in this one. 3x plus 2y is equal to negative 5. And 2x minus 5y is equal to negative 16. Alright, so with this one, I need to get a variable by itself. I don't have one that's just super obvious that I could get by itself. Quite frankly, normally these problems that look like this, I would not use substitution for. I would use combination or elimination. But because it says that we have to solve by substitution, that is what I am going to do. So I'm going to go ahead and I think get this x by itself here. So 2x is equal to, I'm going to go ahead and just move this 5y over. So 5y minus 16 divided by 2. X is equal to 5y minus 16 over 2. And then I take this value and I plug it into the other equation. So this will give me 3 times 5y minus 16 all over 2 plus 2y is equal to negative 5. So here I end up with 15y on top minus 3 times 16 is 48 all over 2 plus 2y is equal to negative 5. Now maybe you remember our handy trick to get rid of this fraction. I can multiply the whole thing by 2. And so that gives me 15y minus 48 plus 4y is equal to negative 10. So I can add this 48 over and combine this to 19y is equal to 38. Y is equal to 38 divided by 19 is 2. Now I need to plug it back in. Ultimately, it really doesn't matter which one I plug it back into, but just for the sake of this problem, I'm going to plug it into the bottom one. I obviously picked the easier one, but 2x minus 5 times 2 is equal to negative 16. 2x minus 10 is equal to negative 16. Add the 10 over. 2x is equal to negative 6. X is equal to negative 3. So then our answer is negative 3, 2 for that particular problem. Okay, so in this case we had one solution. Alright, let's do number 10 and then we'll move on to the next type, just so you can see 2 of them. Alright, 10 is 3x minus y is equal to negative 2, and negative 9x plus 3y is equal to 6. Alright, so with this one, okay, again, it really doesn't matter which variable I pick to get rid of. However, if I use this y here that's by itself, it might make my life a little bit easier, so I won't end up with a fraction. So negative y is equal to, I'm going to go ahead and move this 3 over, negative 3x minus 2, divided by the negative, y is equal to 3x plus 2. So now I'm going to take this, I'm going to plug it into this equation here. Negative 9x plus 3 times, so you got to pay attention here, 3 times and now y. 3x plus 2 is equal to 6. So that's going to be 9x. So negative 9x plus 9x plus 6 is equal to 6. Those go away. 6 is equal to 6. As soon as I get this here, I immediately say This is always true, so infinitely many solutions. So that would be my answer here, is infinitely many solutions. Basically meaning no matter what value I pick, it will make it true. Okay, so the next type says to solve the system algebraically. So this method, like I said, is one you've probably not seen before, so it's probably going to look a little confusing at first, but overall I don't actually think it's too bad. Let's just start with 14. It's kind of already set up for us. Alright, so 14, we have y is equal to 2 times x squared plus x, and we have 2x plus y is equal to 20. So your first instinct initially would probably be to tell me to plug in this for y down here and solve for it, which in some respects that's what we're doing, but what we actually need to do is we need to move this 2x over. So y is equal to 20 minus 2x. And now I'm going to replace this y with this stuff that I have both of them by themselves. So essentially I'm going to get 2x squared plus x is equal to 20 minus 2x. And now I can solve for x. So if I add this 2x over, I get 2x squared plus 3x is equal to 20. And at this point, I probably should move this over to solve the equation, or to make a quadratic equation, I should say. So 2x squared plus 3x minus 20 is equal to 0. And then now I can go through and I can try to factor this. I think it's something that can be factored, so I think we should be good. Let's see, 40, see what we can break 40 up into. 8 and 5 I think should work. Positive 8, negative 5. Yeah, so we'll do 2x squared plus 8x minus 5x minus 20 is equal to 0. Pull 2x out here. X plus 4, and pull a negative 5 out here, so x plus 4, these two match, so I know I've done it correctly, so 2x minus 5 times x plus 4, this is still all equal to 0, and now I'm going to set both of these things up equal to 0, so 2x minus 5 is equal to 0, and x plus 4 is equal to 0, so 2x is equal to 5, x is equal to 5 halves, and over here x is equal to negative 4. Now, normally when I'm solving stuff, I would be done now because I've solved for x, but I have to remember I need to go back up and find what y is, so I'm going to plug these back in, and it doesn't matter which one I pick, so just for ease I'm going to pick this one down here. So, when x is equal to 5 halves, I have 2 times 5 halves plus y is equal to 20. 2's go away. 5 plus y is equal to 20. Y is equal to 15. So my first ordered pair is 5 halves and 15. And then when x is equal to negative 4, I have 2 times negative 4 plus y is equal to 20. Negative 8 plus y is equal to 20. Y is equal to 28. So now my second ordered pair is negative 4 and 28. So those are my two answers for these ones. So these ones, you will always have two answers for this type. All right, let's do one more, and then we will move on to the last type. All right, and I know the algebraically is different. Okay, it's just another method that we can use, especially like you noticed, hopefully, that this one had squares in it, and that was part of the reason for using this algebraic method rather than our other methods. Not that we couldn't have the squared terms, but it does make it a little easier to use the algebraic when you have the squareds and cubes and stuff like that. So let's look at 16, and then we'll move on. All right, 16, we have y is equal to x cubed plus x squared, and we have y is equal to negative x squared. Okay, so here I end up replacing y with negative x squared. So this one does look a little bit more like substitution. So we get negative x squared is equal to x cubed plus x squared. So I'm going to add this over. So 0 is equal to x cubed plus 2x squared. I can pull out my x squared, x plus 2. Now I can set both pieces equal to 0. X squared is equal to 0. X plus 2 is equal to 0. So this just gives us that x is equal to 0. This gives me that x is equal to negative 2. And then I can check my two options. So I have, when x is 0, I'm just going to plug it into the bottom one. When x is 0, y is 0. So that order pair is just 0, 0. When x is equal to negative 2, y is equal to negative times the negative 2 squared. So this you have to pay attention to. I've seen a lot of people struggling with signs in various classes recently, so make sure you pay attention to this. This negative 2 is being squared. This negative out front is not. Okay? So negative 2 squared is 4, but then it's still negative because of that negative out front. So those order pairs, negative 2, negative 4. So there are our two answers for that type. All right, so then the last type is to solve by elimination. Okay, or combination. All right, so let's go with 20 to start with. 20 is 2x plus y is equal to 10, and x minus 2y is equal to negative 5. So when I'm looking at these ones, I want to get something that's going to cancel out here. That's why people now refer to it as elimination more than combinations, because I want to make something cancel. I want to eliminate a variable. And the easiest way to do that is to go with one that already has opposite signs. Okay, so this one is positive, this one's negative in terms of the y's. So I'm going to multiply this top equation by 2 so that I can get rid of the y's here. So I get 4x plus 2y is equal to 20. And then I just copy down the bottom one, x minus 2y is equal to negative 5. So the y's go away, so I'm left with 5x is equal to 15. So x is equal to 3. Then I plug it into either equation. Since the one with x by itself, or since there is one with x by itself, I'm going to use that one. Okay, and you can use the original. You don't have to use the modified equation either if you were to have some, or if you wanted to and you were so inclined. So 3 minus 2y is equal to negative 5. So subtract the 3. Negative 2y is equal to negative 8. Divided by negative 2, y is equal to 4, so then my answer is 3, 4 for that one. Okay, this one is probably my favorite type, honestly. I just like doing this like simple algebra stuff here. And in some cases, like on a quiz or a test or something, like how I said with the first substitution problem that we did, that it's probably one that I honestly would use combinations for. You are welcome to do that as well. You know, I may just say, solve using any method. Now we're going to learn another method in 7.2, and you would not be able to use that method unless I specifically allow you to. There will be specific problems that require you to use that method. But right now, excuse me, you could pick any of these when I give you a quiz. Now the homework, it specifically tells you, so you have to use whichever one the homework tells you, and I will be checking for that. Alright, lastly, let's look at um, 26, and we'll be done. So 26, 2x minus y is equal to 3, and negative 4x plus 2y is equal to 5. Now, both of these have opposite signs, so I can pick either one. Let's just do the x's this time. So to get 4, I need to multiply this one by 2. These are different colors so you can see what's going on a little better. Alright. So then that gives me 4x minus 2y is equal to 6. Negative 4x minus plus 2y is equal to 5. 4x minus 4x is 0. Negative 2y plus 2y is 0. So 0 is equal to 11, which is not true. Therefore, it is no solution for that one. And just really quick to set it up, I'm not actually going to do this one, but 22, I think it is. Yeah, 4x minus 5y is equal to negative 23, and 3x plus 4y is equal to 6. I have opposite signs here, but I can't multiply either of these by something to get the other number, so I'm going to have to manipulate both of them. With this 5 and 4 here, I would just multiply this one by 4 and this one by 5, so I would set it up. Basically multiply this one by 4, multiply this one by 5, to get me 16x minus 20y is equal to, let's see, that's 12, 18, 92, 92, we're going to call it 92, I think that's what it is. 15x plus 20y is equal to 30, okay, so you would have to manipulate both, and then you could proceed as follows, okay, with that, so you should be able to do that, but I did want to just remind you that you can manipulate both, and if none of the signs were opposite, okay, then you'd have to multiply one of them by a negative, there, or use the subtraction method, as some people call it. But hopefully all this makes sense. Hopefully this was just more of a refresher for you, with the exception of the solving algebraically. So your homework for this section is 1 through 25. Every other odd. So remember, in the homework, you have to follow the instructions. Using given method. On the quiz, which is still a little while away, but on the quiz, you could pick your method. Okay, so this way I can see that you understand the methods, and then you'd be allowed to pick which one you want to use on a quiz. Most likely, I would give you that option. So, hopefully this makes sense. If you have any questions, remember, let me know, and I will do my best to get back to you as quickly as possible.